Hi guys, sorry I'm not there with you today. I would like you to take out your homework, even if you turned yours in. Please go up right now and collect your worksheet so that you can actually go over this with us. So I'm going to ask the sub to pause this for a second and then let everybody get their worksheet and then start the video up again. Okay, so after you guys check your answers, obviously with this, the back page was kind of the big idea of the homework assignment. Questions like this: does the commutative property work for matrix addition? And what about for matrix multiplication? And then it asks you to give an example or a counterexample for each. Now, the commutative property does work for addition, okay? And if you look at examples 2 and 3 on the front, you're going to see that that's where it's shown. It does not work, though, for multiplication. So this is where we get the idea that, A times A inverse, or I'm sorry, A times B is not the same. Jeez, I can't even write this right. That A times B is not the same as matrix B times A. So last night in the video when we talked about multiplying A inverse B, that you can get a product for, but B times A inverse you can't multiply, so you have to do it in this particular order, and that's how you have to put it in your calculator as well. So yeah, I just wanted to go over that with you. And then the associative property, which works for addition, examples 4 and 5, check that out in the front. You should have the exact same matrix, as well as for multiplication, examples 11 and 12, you should get the same thing. Now I want to show you how to put that on there for examples 11 and 12. Okay, so on number 11, I actually want to enter h times d first. So in my calculator I have this stored. When I hit h times d, I get this new matrix. And then I want to call up matrix C first, because the order is important here. I want to take C and then multiply it by this matrix here. So if I enter second matrix C, and I don't need to store necessarily that one because I can just hit second answer and it'll call up that last matrix here. And when I hit enter, I get this matrix 10, 15, 16, 24. Now this one is a little bit more straightforward to actually put into your calculator, because you can just put C times H and then multiply that answer by D. But you do get the exact same thing. So this property does hold true here for matrix multiplication. It just doesn't when you switch the order of the multiplication, like, let me put that away, like in problems 7, 6, and 7 here. A times B is not the same as B times A, clearly, because you get two different size dimensions here. Okay, so this next question I think is kind of confusing and written in a way that I don't think makes it very clear what it's asking, but is there an additive identity matrix so that if you had a matrix, let's say that matrix was 1, 2, 3, 4, what can you add to this in order to get the same matrix? Well, that matrix has to be full of all zeros and has to be the exact same size dimension. We call that the zero matrix. So there is a matrix and we call it the zero matrix. Now the next question, number 4, says, is there a multiplicative identity matrix? And if so, what is that matrix? Now, it's actually shown in problems 13 and 14. If you look at these two problems here, when we multiplied I times D and D times I, we got the exact same matrix. And we were multiplying it by this matrix here, 1, 0, 0, 1, multiplied by D. And it didn't matter the order here, we got the exact same matrix. This is called the identity matrix. Now, if it was a 3 by 3 matrix, it would look like this, and that would be a 3 by 3 identity matrix. If it was a 4 by 4, it would look like this. And I think you get the point. So as I increase in size, that's called the identity matrix. Okay, so it's always, you can think of it kind of like a square. It's a 3 by 3 or 4 by 4 or 5 by 5, 6 by 6, and so on. Okay. Okay, and then this question here, does every matrix have an additive identity matrix, so that you have your matrix plus the opposite of your matrix to equal 0? And if so, what is that matrix? If you were to take that same matrix I was talking about hypothetically, 1, 2, 3, 4, what can I add to this in order to get the zero matrix over here? Well, if I take each one of those and I multiply it by its opposite, then I would get all zeros. So if I were to distribute that negative to each one of these here and change that to an addition problem of all the negatives, its opposite, then I get the zero matrix. So as long as you have the opposite of matrix A, you will get all zeros. Last but not least, question number 6 here. Does every matrix have a multiplicative inverse matrix? And if so, what is that matrix? So the big idea here is that not every matrix has an inverse, because if the determinant is 0, there will be no inverse. So in example 18, when you try to type that in your calculator, D inverse, and hopefully when you type that in, you hit second matrix, scroll down to D, and then there's an inverse key right actually the matrix key is the inverse key too. If you hit that, now you can see I get this error message, singular matrix. So this is just an error message because this didn't have an inverse, because if you look at the determinant of that of this particular matrix, you get 0. So that's why not every matrix has an inverse, but if it does, what's interesting is that if you multiply, it doesn't matter the order. So let's say I do have an inverse for that matrix, I would get the identity matrix after I multiply the two together. So that's called the identity matrix when you are able to multiply it. Okay, so the inverse is here, and you result in the identity matrix when you multiply A times its inverse. Okay, or A inverse times A. Okay, make sure you also check your answers to the second part with the no calculator. I just want to make sure that you're getting the skills right, that you're multiplying and adding, dividing, or not dividing, but adding and subtracting and finding the inverse correctly. So please go ahead and check with the key. Please be super nice to the sub, and I will see you guys all on Tuesday. So please go ahead and get started on your homework for day 9, and then check your answers with the key. It should be up at the front, and have a fabulous weekend.